In this video, we're going to talk about how to solve rational inequalities. Okay. So let f of x be a rational function. Then a rational inequality is of one of those four forms. All right, so solve the following rational inequalities and write the final answer in interval notation. Now, with a rational function, we know the zeros are in the numerator and we have restrictions in the denominator. So this is what makes this different than solving a polynomial inequality. Okay, so zeros. Set the numerator equal to 0. And factor. So we know x is equal to -3. Restrictions. Okay, x cannot equal 0. So similarly to what we did with polynomial inequalities, why don't we put these on a number line? Now, because -3 is a 0 and the inequality sign is less than or equal to, -3 is included. Now, 0, that's never going to be included. That is a restriction. Right? So let's do test points for each interval then. All right, so let's try -4 first. Okay. So when we plug in -4, so that's 1 divided by -4, and that certainly is less than or equal to 0. So we can include that particular region. Okay, second interval. Let's try it -1. So that's 9 plus 1 is 10 minus 6. That's what, 4 divided by -1. That is also less than or equal to 0. Okay. All right, so now let's try x equal to +1. So 16 is less than or equal to 0. That is not a true statement. So the solution for this is actually one interval. It's from -infinity to 0. Okay. So to solve rational inequalities, get all the terms on one side of the inequality and get the rational expression as one term. Calculate the zeros by setting f of x equal to 0, determine restrictions, and place all zeros and restriction values on a number line. These will all be considered boundary values. Do a test point in each region to determine which interval or intervals make the inequality true, and then write the solution in interval notation. Okay, so let's try one of these then. So again, first thing I want to do, because everything is on one side of the inequality now, is determine what my zeros and what my restrictions are going to be. Okay. Zeros, I'm going to set the numerator equal to 0. And then my restrictions. Okay, so let's put these values on a number line then. Now, 4 and -3 being zeros, because the inequality sign is strictly greater than, these values are not going to be included. Okay. Now, for your restrictions, on the other hand, again, because they are restrictions, they are never going to be part of the solution for this. Okay. So because I have 4 boundary values, that means I have 5 different values I need to test for this. Okay. So the first region on the left, let's try -7. Okay, so plugging in. So that's what, 44 over 13. Okay. That is greater than or equal to 0. So I can shade this region. Okay, second region, let's try -5. So plugging in. Well, that is certainly not greater than or equal to 0, so that region will not be included. Third region, between -3 and 4, well, we're going to try 0. Easy to simplify, and 1/3 is certainly greater than 0. Okay, fourth interval to test, between 4 and 6, let's try 5. That's what, 8 on the top, -11. That is certainly not greater than 0. Okay, okay, the last interval, let's do 7. Okay, so plug in. So that's going to be what, 30 over 13, and that is greater than 0. Okay. So I can shade this last interval in. So my last step now is to write this in interval notation. So any number that is in any of these intervals will make that inequality a true statement. Okay, one other example I want to take a look at in this is where I do have a fraction I have to move. So again, the very first thing I will do is I will subtract 1 over x. Now, in order to simplify fractions with addition or subtraction, I need to come up with my LCD. Well, LCD in this case is x times a quantity x plus 3. Okay? So let's do the LCD part, and I'm going to change it. Well, I'll leave the inequality for now. So what? Multiply top and bottom here by x. Here, I'm going to multiply top and bottom by x plus 3. Okay. I'll rewrite this as one fraction. Okay, distribute the negative. I'll put that over here. Okay, now I finally have one rational inequality here. Okay, so again, I can identify my zeros. Okay, again, that's the numerator. That's x equal to 3. And my restrictions. So now I'm going to put all of these on a number line. Now again, the 0 is 3, so because it's greater than or equal to, I am allowed to include the 3 as a solution. And again, because 0 and -3 are restrictions, they are never included in the solution. Okay, because I have 3 different boundary values, that means I have 4 different intervals that I need to check. So let's start with the first one. Let's do x equal to -4. Again, I will go here to check. So that's what, -7. And then -4, -1, -7 over a +4. That is not greater than or equal to 0. Okay, second interval between -3 and 0. Let's do -1. Okay. So that's -4 divided by -2, and we know 2 is greater than or equal to 0. So So this interval would be included. Okay, third interval between 0 and 3, let's do 1. So, okay. So that's what, -2/4, and we know that's not going to be the case. I don't need to simplify to know that that's going to be a false statement. Okay, fourth interval, something bigger than 3, let's do 4. Okay, and 1/28 is greater than or equal to 0. Okay. So again, my last step here is to write my final answer in interval notation.